friends, in the previous video we learned about Einstein's theory of general relativity, and in this video we're going to learn about time dilation. Time dilation is used to prove the second principle of general relativity, which is that light speed is always constant. So time dilation is used to prove the second principle of relativity, that time is constant. Okay, so what the main concept of time dilation is that how motion affects time. How does motion affect time? So now let's give an example for our time dilation topic. So let's use a light clock. But before we use a light clock, we need to know what is light clock. So there's nothing. A light clock is nothing but two mirrors that are parallel to each other. Like this. Let's say that these are two mirrors. And light is getting reflected here in this mirror and again coming back up and reflecting in this mirror, and this cycle goes on. So this is only a light clock. So let's say now that when the light reflects on the top mirror, it is called as a tick, and when the light reflects on the bottom mirror, it is called as a tock. So tick tock, this is only one duration. This is what a clock does. It does tick tock and also measures the duration between two events. So now we know what a light clock is. So let's learn about our time dilation. So let's say that here I'm drawing my light clock again. I'm drawing my light clock. This is getting reflected here and this is also getting reflected here. But if this light clock is stationary, let's say that this is stationary. In your perspective, how would you see this clock? How would you see the light reflecting? You will see the light reflecting normally, going up and going down. So this is how you would see the light reflecting, just a straight line up, down. So this is how you will see. This is how your perspective will be when the light clock is stationary. So let's say that if this light clock is in motion. Let me draw the light clock again. Two parallel mirrors and light is getting reflected. But this is in motion, right? So let's write down this is in motion. I can't draw this like this. You know how? I can't draw it like this. Why? Because light has to travel at height but also horizontally, because it's in motion. Let's say that it's going at the right side or left side for you. It has to travel both ways. It has to travel up and east. Or for me, it's east. So in your perspective, you will see that somewhat will be like a northeast. So we will see the light going from the one side of the bottom mirror getting reflected to the top mirror, and this is only the tick, and this is where you will see the light coming tock. It's like so when stationary, it seems to look like a straight line, but when this is at motion, you would see this is going in upside down V, or you can say it as A. So this is how you see. For stationary like this, for motion, lights will be like this. So with this, we can define about the time dilation. So here, if you can see, the distance is small. Distance is small here. But if you can see here, there's more distance. But first, let's write our speed formula. I'll tell why. Speed is equal to distance by time. So here, light speed can always be denoted as c. So c is, because here we are using light only, distance. Here there's more distance. Okay, so there's more distance. Okay, if there's more distance, then there will be less time. That means time will be slowed down. If there's more distance to go, time will be slowed down. So that means when this light clock is going in motion, time slows down compared to the stationary clock in your perspective. So the stationary clock, there will be more ticks. The ticks will happen quickly. But here, because due to the time being slow, the tick tocks will be very slow, like tick tock. But here, tick tocks might happen very quickly. So this is only an example of time dilation. So now I think that you know what time dilation is and how we can prove time dilation. in an example. Please do like and subscribe to my channel, and thanks for watching this video. Bye.